Good evening, ladies and gentlemen, companions world over, Americas, Europe, Africa, Australia, Latin America, and all world over. I welcome you, LISA International Academy. LISA standing for Love More International Science Academy. You find the videos I've done before explaining. Let's go straight to the theoretical part of level 2, tertiary education, where I discussed about the first topic being, for level 2, being numbers. It is very important that we start to discuss the theoretical part of mathematics before we go practical, because there's correlationship between theory and practical. So if we don't have theory as our backbone, we would not have enough flesh to feed on our skeleton. So it's very important that we understand the theoretical part and all the concepts, including the principle needed to continue with such a topic. At this level, students are coming from all over places whereby they've done different type of education. At the higher education, we would introduce them to number system, for the first topic being numbers, just simple numbers. What are numbers? Where did they come from? Why are we having numbers here? So those students would not know how. We are going to explain a lot about that. Let me continue with the next aspect. The first one being number system. We are going to discuss deeply about what number system is all about. There are sets which form it's quite historical, if I am to say. Second, we are looking at rational and irrational numbers. Thirdly, we would look at terminating and recurring decimal. This is very interesting. It gets a little bit algebraic when solving such situations. By then, students don't know anything about equations, neither did they know anything about algebraic expressions. So it is really tough for students to understand that particular methodology which we use to find a terminating or recurring decimal. That being said, we shall discuss further in the practical manner. I'll be forwarding those videos when we are on a practical occasion. Now we are on the couch with mathematics on the couch. Fourth, laws of exponents, laws of powers, laws of laws of logarithm as well. One and the same thing, but different authors. So you should not be confused by the terminology, but they're talking of, what are we talking about? The laws of indices. We shall immediately divulge into them at a much profound analysis. Fifth, how do we rationalize the denominator? Rationalize denominator. Then sixth one, we add, subtract, multiply, and divide simple sad. What is a sad? We know exactly that there are those numbers: square root of 3, square root of 5, square root of 7, those prime numbers. And you take a square root of a prime number, usually we don't have an answer to that, so we call it a set. In another term, it's a rational number. It's like it doesn't have brains, it doesn't reason, it is not rational. That's how we would explain to students, if you really want them to grasp the concept. The seventh one would be manipulation of formulae and substitution thereof. You're given a particular formula. In this case, We haven't told them we are talking of a linear equation or a linear function. We just give them an equation or a formula to deal with, making y the subject of formula, for instance. At the back of their mind, they don't know that they're dealing with equations. But at a later stage, they would have interiorized, because there's correlationship between any concept. It's like a spiral development. So at this stage, it's very important we should handle the students with care, because it is tough for them. Once we lose the best, we are lost. Okay, last but not least, arithmetic sequences and series. That would be part of what we are doing in level 2. First topic on numbers. Now, I have here with me a textbook which I usually use. Let me go a little bit step by step. I was talking of a number system. Where did the numbers come from is my question. Who first thought of numbers? Where, in which continent were numbers originating from? But theoretically, I would say, in this philosophical type of means, you would say maybe there was someone who was just walking by and they met, and they probably had a child. They saw the child growing nicely, being a lad. And of course, they expect the child to start to walk. That's the wish of every parent, to see their child walk. So they would just see, oh, the child is walking. The first step, 1, 2, 3, until they cannot chase him anymore, up to the infinity. That's where we started to have what we call natural numbers. It is a set of numbers which start from 1, 2, 3, 4, and so forth, up to the positive infinity. Why natural? Because the child would have done those steps naturally. But then there is a situation whereby maybe the child would not be having the ability to walk, no steps at all. We have to consider that particular data, because it's a human being. So we would say, oh, no steps, 0, doesn't move anymore. So if we put a 0 in natural number, thereby we form yet another set of numbers, which we call whole numbers. I will put it directly on the whiteboard for us to work when we are doing practical. I'll be doing it as we do practical. Now let's just go theoretical. So natural numbers build up to whole numbers. But fine, it's fun. Here sometimes in Africa the temperature will never get to a negative. But in Europe, in Ireland for instance, you visit that, find the temperature is below 0, as they say. Would we not consider such people to exist in the world? No, they exist, but in their own particular condition. So the number would also go into their own environment, in their ambient. So what would they study that set of numbers? They say, okay, if we include the 0 minus 1 to the negative infinity, and all that we have said, the natural numbers, the whole numbers from the all negative numbers. What name did they give them? They said those are integers. Integers. It's quite interesting that this little book tells me a little bit about those set of numbers. If you look, you can have another textbook of your own. No, it doesn't matter. Here we have integers there. But not all the numbers are in the form of whole numbers or integers or natural. You can have to divide a loaf of bread amongst two brothers, half half. That is a ratio. It's a ratio. There's a reason. You are reasoning that you won't be selfish. You're dividing. So they say, what type of numbers that you have division or fractions? They will say. We say, okay, that those are rational numbers. So it's a set of rational numbers. Okay? Then there are also different numbers, which even if you want to try to be friendly to them, they don't reason. They say to them, they call it them irrational, like they don't make any sense. And which one are these irrational numbers? Remember, we are talking of the integers. Now we are putting rational numbers in between the integers or negative, anywhere they fit there in the whole x-axis. Okay, where are you? It's a set of numbers, rational numbers. We have something like square root, the third root of minus 8, which is minus 2. Minus 2 times minus 2 times minus 2 gives us minus 8. Minus 2 over minus 3. 0 also a rational number. So irrational number are those which I have just mentioned. 1.5, 4. Because you can write 4 over 1. Rational number. Then which are irrational number? Square root of 5 is a sad. Pi. A number which is a common moves on off infinitely without any pattern. Makes no sense. It's not like others, the fraction or decimal numbers which are organized, which recur, which terminate, which finish. Like 5 over 10 is half, 0.5. Half. It stops, terminating decimal. But there's another number which goes on and on. Square root of 5, for instance. Those are not making sense, and we put them under irrational number. But all that being said, what is all we talk of all those numbers in between? They said the whole set of that. At this level, we call them real numbers. Real numbers at the x-axis or the y-axis is composed of real numbers. We shall discuss this at a later stage when we are discussing about function and algebra. That will be maybe the second topic. But for the time being, we stop here at a level 2 because we can't go deeper than what will be the square root of minus 2. The old one say it can't mean error, can't say minus 2. The calculator said minus 2. Then we stop there because at this level they can't continue with that unless they pass to the next level, which is level 3, where they say it is becoming a complex situation. We'll talk of the complex number at the next level, which we shall tackle amicably. So those are the set of numbers. I think theoretically we are done with that. The rational number, we talked about that. We also talked about terminating and recurring in theory. Laws of exponents, we talk about them. They are so interesting. They have their own ways of understanding. Any number raised to power 0 is 1 of them. Any number raised to a negative is 1 over that. To a negative power is 1 over that number to the power of that negative. Those are some of those we shall do. How do we rationalize a denominator? We rationalize a denominator if actually we are having an irrational denominator. To make sense, if the square root of 5 is the denominator, we multiply with itself so that square root by square root it is positive. Using laws of indices up there, there exists correlation coefficient positive between matter or between material of the concept, because we have seen laws of indices, laws of powers. So you can't divorce any concept, mathematically speaking, because it's a speed of development. So at this stage, you would have done that particular intervention in the student's mind, that he has the theoretical part. When you go to practice, it's about individuality, independent work, which we discourage, copy and paste. Most of them, they just want to just see someone doing it for them. And they take it wrongly because they think mathematics is all about numbers. No, it's not about numbers. Look, we are discussing. It's quite interesting. When we go to the practical part, it's business all day. Okay. Addition, subtraction of the sides, we shall look at them. There is a condition we should not forget, the conjugate. We shall talk about it when we go practical. Adding, subtraction, multiplication, and division of simple sides. It's going to be very interesting. Manipulation of formula and substitution we discussed about. Arithmetic and sequences. So ladies and gentlemen, that would be theoretical part of this level 2 mathematics at the tertiary level. The practical one, we will send it through the link so that you can comment, you can bring in any more questions, then probably we could discuss and enjoy ourselves in this particular. Thank you so much. Good evening.